Okay, I'm making two parts of a video. Okay, in this video, we're going, if you notice what page I'm on, we're going hour by hour by hour, and we're looking at solar and wind together, solar and wind together, and we could be looking at some sort of microgrid where hypothetically you might have solar and wind. We could be looking at responding to a request for proposal where we're trying to meet a target demand. In a distributed generation, we could look at our demand and we could put wind and solar in and see how much surplus demand or deficit demand we have. So we're going to do a whole little analysis of solar. And then we're going to put the wind together with the solar. And then we're going to see if we can, how much of the demand we can meet with the wind and the solar together. And finally, we'll put a battery in and we'll put a minimum state of charge and a round trip efficiency for the battery. And ultimately, we'll see how much surplus energy we have together with this battery or unserved energy we have with this battery. And we'll look at the little Weibull distributions. Most importantly, we can look at different selected periods. Let's look at month 6. How's that? Let's try month 6. And we'll look at hour by hour by hour. Now, recently especially, a lot of the videos and postings to my website have been about financial models, not about this hour by hour kind of stuff. But if, let's say you're making a hydrogen analysis and you're trying to make a green hydrogen, which means you have to take solar and wind and get all the energy in your hydrogen electrolyzer from green energy, and you want to produce it here with this kind of pattern every hour. If you don't look at things hour by hour, how can you understand things? And you might say, we've got technical engineers to do all of that. I don't have to do that. They're going to just give me the numbers. I couldn't accept that. You have to, please, go and try this and try to understand it. And it's not that hard. You can watch this whole video, and I've tried to, in this video, I've gone through the Excel and how to get there. Okay, and let's look, and in this case, we put the solar here. We add to that with a stacked area some wind. We've got too much, and then we can put it in the battery here, but then we don't have enough to meet here. We're going to have to go buy some extra power, or we're going to have to produce less from our hydrogen in this hour. And unless you see this hour by hour, let's go back to April and see what happened in April. Unless you see it hour by hour, and unless you're not afraid to say, I'm going to spend about, in this case, maybe 2 hours. I'm going to get some of the hourly data. Everything I've gotten to show you how to do this is from hour by hour data. And so the theme here is really, don't be afraid. Look at this. This is even better. Now we have all this extra. The problem here is that the wind is coincident a little bit with the solar, and then at nighttime we don't have enough wind, and then we have to discharge the battery. That we can look at that, and then even better, not even better, it's probably less good in a way. Then we can do some sum ifs. In this case, we do the sum if with the EO month. It's so easy. The Excel is so easy once you've got have the hourly data, and you're not afraid to take the hourly data. And even if you're not using it, you can understand what's going on here. And then you can say, okay, in our financial model, what can we do with our hydrogen strategy? We can get the solar and the wind, and then take the stuff from the battery discharge, and then we've got to sell this energy on the market, and then with the unserved energy, And then we do this month by month, assuming that of course, we can use a different year here and see how sensitive this is to a different year. And we can see, okay, we can either, with our unserved energy, produce less hydrogen, and then you have to deal with the question of the question of whether an alkaline electrolyzer can really run. You can ramp it down and ramp it up, okay, and you can think about, well, all right, with the surplus, maybe we can do a little bit further analysis and say, okay, maybe we can run this up to 100% of capacity, but sometimes you're going to be above 100% capacity. And then in your financial model, the battery might be kind of expensive. That's unfortunately, the battery has a life and a degradation and other things that might make it expensive. If we take a different strategy and just multiply this by 0, okay, that means we're just going to take the battery all out of this equation, and then we look hour by hour by hour and see what happens. If we don't have a battery, we'll have more surplus and more unserved energy when we do that. But maybe that's okay. And maybe we can reduce the size of the solar and the wind, and maybe we can run our electrolyzer ultimately with a lower capacity factor. And now we don't have any, we can see how much surplus and unserved energy we have. And we can just change all the parameters. Now, to run this, you've got to do a little bit of analysis on you put some detailed data in for things like the temperature coefficient on the solar. You put this is all from public data, no cost. I didn't spend a penny on this as usual because I can't afford to. We put the wind inputs. We put some hydrogen, which is really our demand. This demand, again, could be apartment building or it could be any kind of commercial building, distributed generation. And then you put some battery characteristics in. Here's our power curve for the wind. And then here's an illustration of how you work through the dispatch, essentially, of a battery, and a little more information kind of on the performance ratio of the wind. So if you now watch the video, I'm going to go step by step from collecting the hourly data and then showing you how it all works. Okay, and I've got this in 2 parts. Part 1 will be a little bit of an introduction, and part 2 will work through the hour by hour by hour analysis. So let's get started. Okay, this is a video about hydrogen, but it's really about putting a solar and wind and battery together and seeing what kind of cost we can get for our hydrogen project. What kind of cost could we get when we put all of these together? And the issue is to do this in some kind of crude way. Perhaps you use PV cyst or something like that and could get hourly data even. You could go to your wind analysis and try to get hourly wind data. But let's just say we have the same capacity factor. Pretend this is the same for wind and solar. It's not. We have a very, very high wind one in this example. If we have a high wind capacity factor, let's just pretend they're the same just for a moment. If they're the same and the hourly pattern is exactly the same, then the overall capacity factor for our electrolyzer will be, let's say they're both 30% or 25%. Then this would be 25%. On the other hand, if this was 25% and this was 25% and they're totally non-coincident, so they don't move together, then we could get a much higher capacity factor and run our our electrolyzer much more. Now, we could put a battery in to try to smooth it out. If we have a target capacity factor, we can then say, okay, let's see how much battery capacity we would need if we put different levels of solar and wind capacity, and how much extra solar and wind would we have. Now, to do this correctly, I cannot see how you could not do it. We have too many knots just there without hour by hour data. That's the idea. Now, if you go to PVGIS and whatever, okay, and then we go down here, if you go to this solar radiation, it says solar radiation, and what we're going to do is not use it for solar. We're going to get the hourly data, and I'm not going to go through all this because I've already done it. And what I have done is get the hourly data for this latitude and longitude. Okay, I put those in, all right? And when we do this, now, in the old days, this was not here. I assume this WS means wind speed. I don't think I'm crazy for saying that. So they have this one, which is the, this is, if we're really careful here, we would put this as watts per meter squared. This would be, I'm not sure, but this would be degrees centigrade, not Fahrenheit, okay. And this would be meters per second. And look at this. This is just wonderful that we now have this. Now the question is, because this is something that I think they're probably about to, I don't know, test it out or do something with this. Is this good data or not good data? Now, before I answer this, what we could do is we could put our wind analysis together with our solar analysis, and that's what I'm going to show you, putting wind and solar together and doing a reasonable mimic of PV cyst, and then doing a reasonable analysis on the wind, and at least getting this issue of coincident usage resolved. Okay, and what we can do then, and I hope I'm not going to take too long to go through it, but for the wind, there's this, we can go to the Global Wind Atlas first and compare the wind data from the Global Wind Atlas to this PVGIS data. But we have to make some adjustments for the height, because the wind are if you go upstairs and go high to a hill and go outside to a balcony that's a little bit up high in your apartment or something, it's going to be a lot windier there, or somewhat windier, I don't know, than it is down way if you put your hand down on the floor, okay? And then we can find some power curves. Now, there's this website that gives you power curves. Now, they give you some samples. It's hard to get this. They want to charge you money. And, of course, what I do is this is all free stuff. All of this is free stuff. And then we finally have to kind of get our downtimes. It's almost like a performance ratio. So here's what I did. It took me a long time to do this. I found a place in Oman. And this was at 100 meters, and they said, 8.21 meters per second, plus it's really sunny in Oman, plus it's near the ocean. What a wonderful place to do to see if we can be a little competitive with a green hydrogen project, okay? And then the problem is that's at 100 meters. Now, if you go through, there's this wind shear adjustment. This is the wind speed, okay, and we take the wind speed at 10, and we take 100 divided by 10 raised to the alpha power, and they said, use the 1/7 power law. I'm sorry, I don't know why that's appropriate, but okay. As a first approximation, that gives you 0.143. So you could take that hour by hour data and take 10 raised to the 0.143 and hour by hour get the wind speed. But if you looked at, you can back into this alpha, and what this Global Wind Atlas has is they have, at the 10 meters, they have 5.13 meters per second, so they have 8.21, and look at this, the latitude and the longitude better be the same for both of these places, I hope. Yes, they're the same, okay? And you work through this thing where that you have to take the log of the Z2 and Z1. Remember, that's the height, and this is the wind, so you can take the log of this divided by the log of 10 and get this alpha, okay? We could start with that one, but I get 0.20. And then you have to decide, so there are some examples of wind shear a little bit. And then I looked at this video, and Herr Dr. Michel Thowart, he says that Global Wind Atlas is way overstated. Now, it does say here, to give them a little credit, it does say data for the 10% windiest areas, so we have to recognize that a little bit. So what I did here is put the same latitude and longitude and see what the difference is now. To really test this, you'd have to take some actual studies. And finally, when you look at the wind generation, well, they might have the gross energy output, and to get the gross energy output, where did I put just a minute? Oh, I didn't put the pictures of the power curves here. Okay, you can take the power curves, multiply, and do a little bit of a lookup on the power curves to get hour by hour the wind generation, but then you have these losses for curtailment. Environmental, that might be for birds, curtailment might be for transmission, some availability because we've got maintenance, some wake effect because we have the turbines behind each other, and then some line losses. Those are kind of, for me, analogous to a performance ratio in solar. So we're going to put all of those together, and we're going to put the wind and solar together. Now, what I do, I've tried, this is the first time I've tried it. I should not be making a video while I'm doing this. I should have kind of tested it out, but let's see how it works. So I did do some work. I said, okay, well, here are some representative solar inputs for how the production of a solar project could work. Here are some wind inputs, and I used this alpha that we just talked about. And let's put a performance ratio. I won't call it performance because then you'll yell at me. Let's say we get 90%. Okay, and then I'm going to say we have some just required hydrogen, and we oversized the wind a little bit. We oversized the solar even more. So we might have to put a battery in. And when we put a battery, we're going to talk about the energy from the battery and the capacity from the battery. So this example will try to have everything together. Now, if you go to that website, I'm going to put this file right now, on my web pages. Here, let's show you where I'll put it. How about I do this? Oops, oh no, come on, here. So I'm going to put it right here. I think I'm going to put it both in, I might put it in all three of them, in the solar resource analysis and the wind resource analysis. So you can do this hour by hour thing. And what I'm going to do is put this, oh gosh, I've got too many files open. I've only got a few files open, really. I'm going to put this file in here, and then all we'll do is throw the other file together with this one in it, and let's see now just to finish this up. So this is a couple of different wind turbines, and let's pick the one with the highest kind of power curve. I expressed the power curves as for different wind speeds. This is meters per second for different wind speeds, and then I put much more fine. I used a little interpolate so we don't have this problem where you're suddenly going from one to another. And then I showed you the alpha that we can use, and then I said, okay, well, before we do that, let's talk about. And then I put some of these performance in. So once we have the wind speed, we put the alpha for the wind speed. Maybe I should have done that first. Maybe I should. I'm going to just move that around right now. We put the alpha for the wind speed up here. Let's put that up here. Okay, and then once we have the alpha for the wind speed, let's put the power curve, and we just do a lookup against the power curve. And then we can put the demand profile in. Now, if you try to run this hydrogen at a high capacity factor, I'm going to just use this one as an example. Oh my gosh, we're going to have to oversize the wind and the solar by a lot, and then use a lot of battery capacity. But let's shape this a little, because we know we have a little more solar capacity during the day. So we have some at night, some at day, and then what we're going to do is, because I've done another video on that, I don't know where to find that video, whatever, you can find it, but we're going to put all of these little things here, and it looks like whatever. Let me just do this for a second. We have our soiling losses, and then what we'll have a temperature adjustment where we take 30% of the winds of the solar meters per second, and that gives us 30% is how much we add to the temperature. And then so we get the temperature at the panels, and we finally up here, then we make a temperature coefficient, and I use this temperature coefficient. So we compare the temperature at the panel to 25 degrees, and then we make a temperature adjustment, and then we get a subtotal, and then we have some other losses, which I put as 2.9%. And then we can get our capacity, and then we can see how much excuse me, we can get our subtotal, and then we can see, well, what's our maximum AC output, and did I put an AC to DC here? Yes, I put, in this case, I'll explain why I did this. This is a very not a very high ratio, and that depends on where you are. Okay, and so we put the AC to DC ratio, and we get our number, And then finally we get so we might have some losses because we don't have enough AC to meet our potential load. And then we get finally we get our inverter losses. So I'm going to try to do this now where you can just put all of these things in and you can do this yourself. Okay? And then you get your solar capacity factor, which is how much your output is relative to the STC, to the 1000. I can even put our 1000 in here because remember, the capacity of a solar project is arbitrarily defined as 1000 watts for a meter squared at 25 degrees at 1000 watts. That's our capacity, 1000 watts, and that happens at 25 degrees. And then we can put our solar capacity in here, and we can get do our analysis. And all we have to do now is I tried to put these titles here so we can just move these titles. I don't know if I really have to do this, but just in case, I'm pressing F4s on these things. So then we can quickly get our solar analysis, and I have already discussed the wind analysis a little bit. Okay, and this one was a good one. Okay, and we just copy these titles, and then we had this other file here, and on this other file we just do our things where we put the dates in and what have you. And all I'm going to do right now is move this file. I'm going to take this file and put it in our hourly template. But before I do that, what I'm going to do is save this hourly template without any of the hourly data. So the idea is Alt-E-M, and the idea is that you can then, where's our, hourly template. Let's put it before sheet 1. That was kind of an extra sheet. Okay, and then we'll do this. And I hope I didn't even create a copy. Good. Oh no, I did. So we don't need this anymore. Okay, good. And now we have the generic macros is open, and now we have this data, and now we can just grab this data from this file and do our analysis. Now let's talk about the battery just for a minute. And I think maybe we could, I don't know if we should do this all in one sheet. Perhaps we should. But the trick for me with a battery is you start with how much solar and wind you get from what we're just looking at above. We just went through and said, oh, okay, here's our wind speed and our power curve. Okay. And then there's our demand profile. So I said we've got a capacity of 120,000 kilowatts. We want to get some kind of capacity factor on this. But we don't know, it could be, we could make it just flat. We could just make it flat. Where did I put this? Here. Oh, come on. Where is there's our demand profile, excuse me, demand profile. I could say for hydrogen, but I don't want to start changing this. I'll do this for hydrogen. Okay, and then we can, this is our solar titles. I see, I did this wrong. Oh, I've got to fix that in another template. Well, I'll put it here for now. Okay. Titles. Okay, so we're going to put all of this together. Now, when we go, the final step is making our battery. And what we want to do is in our financial model eventually say, well, over the course of a year, I guess, or a month, we can do it monthly, whatever, weekly, whatever you want. Okay, hourly. We're going to start with hourly and then aggregate it. But we're going to have some hours. We're going to go through hour by hour. And my first step is always to get the total amount of production we have from renewables, compare that to the total demand. And I just made a simple little example where we have a flat demand. If we have surplus production, we're going to be able to charge the battery. When we have deficit production, we're going to discharge the battery. Now, I've done this many times and I've done it so badly, but let's put the capacity of the battery in kilowatt hours. Okay, and then just 1 second. Okay, so we, where was I? Now, what I do is after we put the capacity in, we need to have some kind of data on the minimum charge. Now what I have done here, I hate to do this, but for the battery, I have done something kind of really bad. I've just, I hate using these stupid things where you use sports analogies in American football. There's something called a punt where you just kind of give up. And where did I put this stuff? Just a minute. Did I not? I just said, okay, let's just use Lazard. They get it. I've made that other video, talked about them, but they have an efficiency, a round trip efficiency of 91%. They have a depth of discharge or a minimum state of charge of 90%, depth of discharge. And then they don't show what the degradation is. They claim they've done that. Degradation will be really important in all of this. And I'm going to make a separate video that just works through all of those kind of issues. They have a fixed charge per kilowatt hours, a lifetime of 20 years. I don't know how you get a lifetime of 20 years without replacing the battery a lot and making CapEx implicitly or explicitly to do that. And then they put this initial cost, which is a little bit lower these days, and that's one of the reasons I used it. So let's use that, about 300 USD per kWh, and that's supposed to cover everything. So that gives us a starting point. Of course, you put your own characteristics in there. Okay, and what happens with me is I always forget, how do I do this little kind of opening and closing balance like we do for debt? But when I do this for debt, if we have a minimum state of charge, we have to make sure that our closing balance is never less than this minimum. And we can do a couple of little tricks. So first, step one is to compute the minimum state of charge, the 90% minus the 10%. And then we say, well, how much is the maximum we can discharge? And the maximum we can discharge is that we always compare things to the opening balance. So what we would do is we'd like to take the whole opening balance and take the whole opening balance and discharge that, but we can't do that. Well, we can't do that necessarily because we have to keep some minimum state of charge. So you can see this is the amount we took out. And then when we get into this opening and closing balance, it's a little bit harder than the debt balance, but our charge is based on positive, and we can't charge more than the maximum allowable charge. And the maximum allowable charge is simply the amount that we of our capacity minus the amount we've already charged. So we can't charge all of this. In this case, we'd have some surplus generation. And I should have put that down here, I guess. Oh no, I've got to put some unserved energy. I put this in small, unserved. When our battery is not big enough to do it, or we could have surplus generation. Okay, we could have either one of those, and I just tried to show you this little example before we go through it, because if I start going through this with hour by hour data, it's the same thing, and you can see it, but I know I'll make a bunch of mistakes, and I've had to try this many times. So these parameters come from upstairs, and basically this has exactly the same thing, but in the format where we can look at it on an hour-by-hour basis. And I put the little formulas for minimums here, okay? So again, this will be on the website. And now let's just start doing our analysis. And if we start doing our analysis, well, this is, and again, now I'm going to just get the dates right first. And the other thing is I put the for me, this is a really big deal, is to start here. We start with, now Oman is let me see, 1, 2, 3 hours, I think, plus GMT. No, let me see. Europe is 1, 2, I think 3 hours. Let's put this GMT, okay? So we put 3 hours, and then we put the 112005. Now, when I downloaded this from PVGIS, I've done this many. Oh no! Oh, stupid thing! I didn't mean to do that. Okay. Oh God. Okay. Shift Control H did that. So I put a little macro, Shift Control H, in our assumptions, so we can just do it like that. You can look at the macro. It's really, really easy, but for once I'm not wasting time with it. Okay? And then we can say, well, let's add 3 hours to this. And the big trick is taking 3 divided by 24. Okay? And I think I have to subtract 3 hours, but I'll get this right. So let's take our very first hour, and then I put plus 1 divided by 24, so we just go hour by hour, and we have all the formats. And then I need to take that away so I can double click on it. And so we have about 7 in the morning where we start producing, and about 16, oops, it should be probably, let's start 1 hour later. Okay, so we have about 8 in the morning and about 17. That sounds about right. And then we have all of this. Okay, and that's our solar. And this is the in-plane. They call it in-plane. And I keep forgetting what the PV Assist calls this, global incident something or other. Something close to that, okay? And this is the temperature. Now, what you could do is well, let's just do a little bit of analysis of our wind first, okay? And this is the big kind of test. Is there's our man. Okay, Michel, you say that? And he says this is too optimistic. And this is exactly the same latitude and longitude as I took from here, and then and he was probably right, because, well, I don't know if this is right, because this one says, it is 5.13 meters per second. So the very first thing you can do is just do a whole little analysis, and down here, 4.6. But maybe it's just that, maybe it's that because it's the top 10%. So if it's 4.6, let's do this. Let's cheat. Okay, and let's put adjustment. Okay. And let's take our what was this, 5.13? Was that what it was? I'm sorry, I'm really bad at this. It was 5.13. And then we can take the average of this whole thing and, whoops. I didn't mean to cry. Okay, and we get the average of this one, and so our factor is kind of this divided by that, 1.1. So let's just do something really crude and just multiply this, okay? And then over here, once we have these dates defined, which is such the big deal, you know, let's just do a tiny little bit of analysis of the wind. I usually do it for solar, okay? We have 2005 built EIS, and we go to columns, and we went to 2020. Just press enter. You could press tab even and do an average if. Okay, and let's look at we're going to take this whole column, compare it to this one, and take our adjusted column, and since we don't have any years right at the top, we're allowed to do that, and then we can kind of, this is something I wanted to do for a while, and we can see, well, how much variation is there in the wind speed, alternate F1, and this, of course, is stupid Excel. This is so illegal to do it like this. But we can kind of see how much variation we get in the wind speed and get a standard deviation. Okay, and then we can, which is not much, take this one divided by the average, which hopefully is this, or let's put the average. Okay, now I would love it if this was really correct, and this is only 2.5. But then we're going to have to convert this to energy, and then we take if we just did this a P90 on this, we would say equal norm inverse, remember? Okay, and we take the 0.1, and then we say take the average, and then take the standard deviation, and this divided by this is only 3% less, okay? P90 divided by P50. So that's kind of, maybe it's a place where it's not very windy or something like that. And, okay, well, that's one thing we can do. Let's do one more thing. Now, if we, and perhaps, oh no, a little bit afraid, but I can't find it. To find hourly wind data is really, really difficult. Okay, so let's do a little bit of other analysis. Let's say I take our wind speeds and I take them by, let's start with 0.5 and do an alt EIS columns and go to maybe 15 and make our step value 0.5. 0.5. Okay, and once we do that, we can also just take this area, put equal frequency, and this is where it's supposed to not look like a normal distribution. All right, it's supposed to, you take the data array first. Let's take this one, and then we take the bins array here, and it says, well, how many times are we in each bin? And then it's got a whole bunch of data, which is kind of cool. And you can press alternate F1, and you can this is more normal than I would think. It's supposed to be a little more skewed than this, I think, you know? So, all right, well, at least we can kind of start looking at the data, okay? And I'm going to go ahead with the data. I'm sorry about that. Okay, and now let's add a whole bunch of columns. And when we add a whole bunch of columns, does it put the chart over there? Okay, I'm sure I should have just inserted the columns differently. Let's first do our solar analysis. Okay, and I suppose I'm going to keep going. I hope the EU comes up with a good explanation and a good hour-by-hour wind model. Perhaps I'm just not looking around the internet. Perhaps we can find it. But this is our solar titles. Okay. Okay. And let's just put all of these solar titles in. That's what I wanted you to be able to do with this one. So this is the first kind of try of it. And we put it over here. And okay, so did I go too far? And I've still got some place to go here. Okay, so we finally have our solar output. These things didn't work when I brought them over. Shoot, okay. I was hoping that they would work, but I think this might work. Okay, and who cares about the zeros, right? And okay, and so we want, and this is going to be in kilowatt hours. Okay, I should. I'm working on a little template as we go through this. I'm just talking to myself. Sorry about this. Oh, don't give me a thumbs down, please, if you really even made it this far. But it's just, if we could get hourly data, the big deal will be to see just how much how much whatever how much battery we need. And so now let's put the wind speed. I'm going to make this and I'm going to have to put meters per second. I'm going to put this in our other template now. And then we put our adjusted, this is at 10 meters. And then I suppose we could put more than 100 meters, but I'm just going to put 100 meters here. And then this number is going to be this is going to be our alpha. I'm going to use a high alpha like we did for the other one, okay? And then we put kind of our performance. Then we have our gross output and we can just do that as a capacity factor, percent. And this is, I'll just put lookup here. So we're going to look up against that power curve, and this will be a percent. And once we have the percent, then we can put the adjustment okay, AGJ, how's that? For adjustment for performance ratio. And that's we'll put that in percent to, and okay, I'm just going to get that number. Let's just get that number, which we put over here. Okay, and once we finally have that number, then we can put the output. So then we put our total amount of our capacity in here, and we get our wind output. Okay, and production. Okay, and that would be in kilowatt hours again. Okay, so we've got all of this stuff just from getting our little hourly data. We've been able to get all of this things. Okay, I hope that the thing we're of course worried about is that these hour by hour wind speeds are representative really of the wind speeds that our turbine would get, and of course you should really. I don't mean to say this. We absolutely need to do a very detailed study of the wind at our location. That's the big problem with wind. And then finally, let's put our target. How about target demand? And that could be anything. Demand. And then let's put our profile. And so this is our target demand at our capacity we're aiming for, but we're not expecting 100%. So we're going to put this profile with the lookup. We're going to use this down here. We'll use the lookup function, and we'll get this one, and it'll give us our kind of target over the entire period. So you could use this analysis if you could stop here and say, this would be like like an analysis of a distributed generation or microgrid or whatever you want to do with this, okay? But that's what you need. You need the hourly demand and hourly supply. And once you have the hourly demand and hourly supply, then we can get all of this stuff. And it's not gonna work with all of this. And we just copy these titles in here. Okay, and then we put them all together. Oops. I think that's about right. Okay, good. Oh no, I ran out of space here. Okay. Let's get some. Come on! Why didn't that work? Okay, maybe one more just to get it. Okay, so here we are, and why don't I do this? Okay, I've got a phone call coming up. So I'm going to not belabor you with watching me type. I'm going to fill in some of these numbers, including the battery here. Okay, but this is how you can just very quickly do your demand and supply. I think I put it somewhere around here because we need now maybe just one below. Okay, so that's my idea. Oops. Oh, we need to do something about getting the things correct. You know what I might do? I think what I'll do is we'll make another template, and we'll leave all of this stuff in the template, and then basically just have you copy this stuff from your other file and let it just operate and finally get the unserved energy and the generation, and then we make some nice little graphs, and then we can summarize this and get it by hour or by year and see how much we either have to buy from the grid once we add this up together, or how much surplus generation we have to sell, and we try different capacities. You can put different wind speed, different whatever, capacity factors, profiles, power curves, and we can have all of our analysis ready to go into our financial model. So I need a break right now. You need a break too. So we'll stop this and just fill, and then I'll fill it in.